Back then, we were told the isotopes were the same as the Earth's. In 2001, we are told they are different. Bottom line, we know that these rocks are identical to Earth in many ways. The only materials that are uncommon to Earth are also commonplace with meteorites. It seems that Red has taken that into account.
So how do we know they didn't just fall as asteroids? NASA certainly has examples of these that have been collected from various parts of the world. We can rule asteroids out, however, as they all have the scorching and oxidation inevitable from their fiery entry to Earth through the atmosphere. The Apollo moon rocks, of course, show none of this.
We already know that any scars from re-entry would be absent after the materials were retouched in a ceramic slab. And it is simply false to say that the Apollo lunar samples show no signs of oxidation. As Michael Davidson of the Florida State University states in his document, Moon Rocks Under the Microscope, mere basalts are volcanic lavas generally rich in iron and titanium oxide minerals that formed when molten rock from the interior of the Moon surfaced and cooled. Chemically, the rock is about 42% silicon dioxide, 22% ferrous oxide, with the rest being mainly magnesium, calcium, and aluminium oxides. Obviously, how can moon rocks be composed of all these oxides and yet not show signs of oxidation, as is claimed by propagandists and certain other geologists? Graham Ryder of the Lunar and Planetary Institute told Space.com, compared with terrestrial samples, all lunar rocks are oddballs because they are so dry. They contain no molecules of water, they are not oxidized, and they contain no ferric iron. They are easy to distinguish from rocks on Earth. But as demonstrated previously, the rocks do contain water and do show heavy signs of oxidation. Red Zero claims to have received the following email from geologist Callum McAllister. Moon rocks are certainly non-terrestrial basalt in origin and do not match up in composition to any other extraterrestrial rocks, i.e. meteorites. I could go on at great and boring length about QAPF diagrams, intergrown field spars, oxygen-depleted micro and the like, but I won't. So my point is, I know man went to the moon. There's no other way moon rocks could have come here. If they had fallen as meteorites, the atmosphere would have oxidized them in the most obvious way. These rocks are genuine and have spent, over the last 5 billion years or so, in an oxygen-poor, radiation-bombarded environment. Again, as we have seen previously, statements from other sources directly contradict this geologist's statement. How can the moon rocks be composed of God only knows how many oxides and yet not show any signs of oxidation?
When we got the rocks back from the moon, we saw that the isotopes of oxygen in the lunar rocks were exactly the same as on the Earth. Now the reason this is important is that we have meteorites from other parts of the solar system, and each other part of the solar system has a different composition of these oxygen isotopes, ratio of one type of isotope to the other. The moon has exactly the same as the Earth.
How can the moon rocks have exactly the same isotopes as the Earth in 1999 and then completely different isotopes in 2001? You can't have it both ways. Red Zero goes on to say,
and you don't have to just trust Callum here. Hundreds of other geologists have examined these rocks. None of them have any doubt as to their origin. Unless some kind passing aliens dropped them off for us, they must have come from the moon and arrived unscathed within the Apollo spacecrafts.
Let's hear it one more time.
Hundreds of other geologists have examined these rocks.
This is simply false. in actuality, out of all the thousands and thousands of geologists within the scientific community, only a tiny handful has physically studied the lunar material. As Space.com reported on May 23, 2000, about 40 or 50 scientists around the world are still investigating the moon rocks. They have to reply to the curators at the Johnson Space Center with a detailed explanation on how they plan to use the samples and what they hope to learn. Graham Ryder and Callum McAllister are just two out of a tiny few who have actually examined the moon rocks for themselves. Needless to say, with as little as 50 out of the world's entire population examining moon rocks, it comes as no surprise to me why there is seldom any mention, if ever, of oxidation and water being found in the moon rocks. Another characteristic that the propagandists point to are tiny craters supposedly caused by micrometeorites, otherwise known as zap pits. On page 175 of the Desert Publications edition of his book, Bill Casing discussed a method that NASA could have used to fake the tiny craters. There is a laboratory in Santa Barbara that specializes in extremely high-speed impact studies. They've achieved velocities of 32,000 feet per second with a two-stage projectile system. Obviously, rock specimens could be exposed to high-speed particles, thus simulating small particle meteorite bombardment. On his website, Windley responds, stating,
"There is a big difference between the pits formed by the extremely high-speed impact of very small projectiles and the impact produced by relatively low-speed massive projectiles. Meteors strike at a much faster speed than even bullets."
Again, Windley is keeping his readers in the dark and trying to lead them astray using straw man arguments. The average bullet travels much slower than micrometeoroids, but as Bill Casing pointed out, they wouldn't have needed to use them in the first place. Windley neglects to mention that the high-speed impact studies that Bill Casing refers to specializes in projectiles traveling at 32,000 feet per second, which corresponds to roughly 22,000 miles per hour. And as NASA tells us on their website, millions of man-made debris and naturally occurring micrometeoroids orbit in and around Earth's space environment at hypervelocity averaging 10 kilometers per second, 22,000 miles per hour. Windley goes on to write,
Further, such impacts would leave traces of the projectiles in the rock. Substances such as stainless steel or other refined or purified materials don't exist in nature and would be evidence of fraud.
If NASA were concerned about distinguished traces of projectiles being found in the fake moon rocks, why wouldn't they just use projectiles made from the same metallic elements found in the samples, such as aluminium? Which, as a matter of fact, is exactly what NASA does today to simulate micrometeoroid impacts on the International Space Station. Under NASA sponsorship, the Southwest Research Institute developed the Inhibited Shape Charge Launcher, a unique facility that launches aluminium projectiles with masses between 0.3 and 1.5 grams to velocities of more than 11 kilometers per second. It should also be noted that micrometeoroids typically have a mass less than 1 gram. I'd say NASA has got the zap pits covered.